Morning, Year 12. What we're going to be looking at today is something called the Maxwell Boltzmann distribution curve. And why is this relevant? This will enable us to fully understand why increasing the temperature or using a catalyst increases the rate of reaction. Now, just to recap, for two particles to react, firstly, they need to collide and with at least a certain amount of energy. And that amount of energy is called the activation energy. Now, you've got to appreciate that if you've got a sample of a gas, you'll have some particles which are moving really fast, which means they've got lots of energy, and some moving slowly, which means they've got less energy. So you're going to have a wide range of energies in any sample. Now, what the Maxwell-Boltzmann distribution curve does is shows you how many particles have a certain amount of energy. So this graph shows the number of particles on the vertical axis and the energy of those particles on the horizontal axis. And we can see that it starts at 0. You cannot have particles with no energy whatsoever. And we reach a peak, and then we have a long tail. So the area under this graph is the total number of particles. Okay, now I'm going to label just randomly the activation energy. So I'm going to say it is there. So I've labeled it EA. Now, all of these particles here do not have enough energy for a successful reaction. All of the particles under the curve here, and remember the area is the number of particles, have enough energy for a reaction. So I'm going to shade this in. And we know that all of those particles, if they collide, have enough energy to react. Now, I want to look firstly at how using a catalyst changes this. So you should know that a catalyst increases the rate of reaction because it offers an alternative reaction route. Okay, so we are going to get a lower activation energy. So I'm going to draw it on here, and I'm writing EA cat for a catalyst. Now, the effect this has is we can see that now, with the activation energy here, all of this area, representing the molecules with more than the activation energy, it's massively increased. So there will be more collisions with sufficient energy above the activation energy, and therefore the rate of reaction will increase. Now, you might get asked to explain this. So what you need to do, so this is a 3-mark question, you need to say what a catalyst does in the first place. So it offers an alternative reaction pathway with a lower activation energy. And then say that more particles have energy in excess of the activation energy, or more, and therefore, excuse me, I'm not redoing it. Thank you for your patience. There will be more successful collisions occurring per unit of time. And then to finish it off, therefore the rate increases.